Get ready to the countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum. Good evening and hi to all the teachers, parents and the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with Didik Malaysia and Kelab Guru Malaysia with the hashtag bermula percuma, selamanya percuma. So before we proceed, let's begin our session with the recitation of Kitab Al-Fatiha, and for the non-Muslim, please take a moment of silence. Okay, how is everyone doing today? Okay, my prayer is that everyone is in the best of health and ready to proceed with today's class. So let me introduce myself first. I am Madam Rosmaya as your moderator and also a control host for today. I'm a Form 6 Physics teacher at SMJK Yuhua, Kajang, Selangor. And the most important person today is our presenter, okay, Teacher Nun. She is from College Matrikulasi Negeri Sembilan. So let us give a warm welcome to our presenter. Okay, for the record, we are now live on Teacher Nun's channel. So as a sign of support to Teacher Nun for the hard work in preparing today's lesson, so please subscribe her channel and not forgetting to subscribe my channel too. So as usual, the lesson will last approximately 1 hour. The certificate link and the credit claim link will be given at the end of this session. So remember that you can only use EDD email and MOE email to claim the certificate. So for credit claim, you need to collect 1 letter and 5-digit codes. Okay, I repeat, 1 letter and 5-digit codes. So which will be announced separately. Okay, I will announce the code 3 times during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. So I would also like to remind students to use appropriate language and also use appropriate profile picture if you wish to post comments in the chat box. So I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. So please give your full cooperation in making this class a lively one. So stay focused. If you have any questions, please write on the chat box and Teacher Non will try to provide you with the answers. So before I pass this session to Teacher Non, okay, I will announce the letter and the first 2-digit codes for credit claim. Okay, listen everyone. So the codes are A31. A31. Okay, so without further ado, please welcome Teacher Non. You may start your presentation now.
Okay, Assalamualaikum warahmatullahi taala wabarakatuh and good evening everyone. How are you? So thank you so much to our moderator, Madam Rosmaya. My name is Nun binti Muhammad Nun. You can call me Madam Nun. So I will continue with our class today. Before that, I want to introduce you at the Academy YouTuber. We have a lot of subject. We have a lot of subject. For example, here we have the physics PRAYU for the STPM and matriculation, which is led by the Madam Rosmaya. Okay, and then we have the mathematics team, okay, led by Teacher In. Okay, and then we also have biology PRAYU team led by Cikgu Faiza, and for the chemistry led by Cikgu Shahnun, and for the perakaunan and ekonomi PRAYU team led by Madam Fizi. Okay, so Academy YouTube also have apps you can download from the Google Play. In this app, you can get a lot of video, education video, include the physics video for your reference. Okay, So now we go to our purpose today, which is we will do the revision and also a few exercises about the dimension and resultant vector. So this is the first topic for the STPM and matriculation. Okay. Now, before we go to we look at the exercise, I will explain a few related concept. Okay, first about the dimension. So what is dimension? Maybe for the matriculation student, this is new term for you. You never heard about this in the SPM. So dimension is actually defined as a technique or method which the physical quantity can be expressed in terms of combination of the basic quantity. Okay, the technique or method that we want to write down the physical quantity or derived quantity. We can express the derived quantity in terms of the basic quantity, because of derived quantity is combination from the basic quantity. So because of that, we have the dimension for each basic quantity, and the notation of the dimension is the bracket. Okay, if you look at here, this is the bracket which is represent the symbol of dimension. So for the first topic, we use this symbol to represent the dimension, and what we do is we write down the basic quantity or derived quantity inside the bracket, meaning that it is the dimension for that quantity. Or you can write down the full word, for example mass, or you can put the symbol within the bracket which is represent the dimension. Okay, so referring to this basic quantity, for your level now, there are 7 basic quantity that you're supposed to learn, which is the mass, length, and time. You have learned it before, if I'm not mistaken. So what we say is the dimension for mass is represented by the capital letters of M. Okay, and of course all the unit you well known, right? Okay, for the length, the dimension for length is the capital letters of L. The dimension for T is capital letter of T. Okay, and we have the electric current sometimes. Okay, we can find the dimension for the physical quantity that relate to the electric current. So electric current is the basic quantity. The dimension for the electric current is A. The symbol for electric current is I. Please don't confuse. And for the temperature, temperature is a basic quantity. The symbol for temperature is T. Okay. And the dimension for the temperature is theta. Okay, so it is quite equal here, the dimension with the time, so no, don't confuse. And lastly, we have the basic quantity, which is amount of substance represented by the symbol of N. And luckily, the dimension for the amount of substance is also N. So normally for the derived quantity, we focus on the first 3 basic quantity. So MLT, you're supposed to can differentiate, okay, referring to their basic quantity. Okay, so the dimension can be treated as algebraic quantities through the procedure called dimension analysis, meaning that we can use the dimension in the uses or the application of the dimension analysis are divided into 3. The first one is we can use the dimensional analysis to determine the SI unit or any physical or derived quantity. SI unit for derived quantity. Okay, if you want to find the SI unit, we can determine from the using the dimension analysis. Second is we can check the homogeneity or consistency of an equation using the principle of homogeneity, meaning that we want to check either our equation is correct or not. Okay, using the principle of homogeneity. So what is principle of homogeneity? So principle of homogeneity is, if you refer here, I just write down the symbol, but it is actually the equation, the dimension. This bracket is represent the symbol of dimension, right? So the dimension for the LHS is represent the left hand side of the equation. Okay, LHS is left hand side, meaning that for the principle of homogeneity, the dimension at the left hand side of the equation is equal to the dimension at the right hand side of the equation. So to understand more, I will explain in our exercise after this. And the third application of the dimensional analysis is to derive or construct a physical equation. Okay, so for the third application, it is actually more on STPM. Okay, for STPM student. For the matriculation, we focus in these two application, which is to determine the SI unit and also to check the homogeneity or to the consistency of the equation. Okay, and there are few rules, okay, that you need to understand about the dimensional form of the equation. Because of from this rule, then we can solve the related question. Okay, the first rule is if you have the relationship or the equation that involve the additional and subtraction, the way we write down the dimension equation. So the blue equation here is the dimension equation. So we said that the dimension of A, which is at the left hand side of the equation, is equal to the dimension of the physical quantity B equal to, because of this is additional operation, so it is if the dimension is equal. So equal to the dimension of the physical quantity C, and also even it is a subtraction, the dimension is supposed to be equal. Then we can say that this equation is correct or homogeneous. Okay, so this is the first rule, which is involve the additional and subtraction. Okay, all right. Second rule is if the equation involve the multiplication and division. So in this case, the way we write down the dimension equation is very important. If not, you cannot. If you cannot solve the question if you not write down the dimension equation. Okay. So for the dimension of A in this case, okay, for the case B, so dimension of B times with the dimension of C divide by dimension of D. This is for this operation, or if you have these types of equation. Okay, and lastly, if we have the equation like this, which is we have a scalar here 1/2. So if we have the equation of A equal to half BC square power of 2, okay, so how we write down the equation? So this is also operation, multiplication operation. So you need to take note that for the dimensionless quantity, which is 1/2 is dimensionless quantity with no unit, or a certain constant, they are also have no unit. So the dimension is equal to 1. Okay, the dimension of half, the dimension of 2, or any scalar or any dimensionless quantity, it is equal to 1. And for the B, okay, sorry, there is no D here. Actually, no D. So B times C, and then we just square the dimension for C. So it is supposed to have no D here, okay? Sorry for that. So I hope that you understand to differentiate for the how you want to write down the dimension equation referring to the operation of the physical quantity in each equation. Okay, that's overall you supposed to know about the dimension. And from this knowledge, you can solve this question actually. So take a look at the first question. Referring to the first question, deduce the unit of eta in terms of basic unit for the equation below. So given the equation which is f over a is equal to eta times with delta v over delta l, where f is force, a is the area, okay, delta v is the change in velocity. Basically, it is a derived quantity which is velocity, and delta L is the change in distance. So I just highlight with the green color words referring to the derived quantity or referring to the physics quantity. Why? Okay, because of because we want to identify the unit, the function of the dimension analysis is can identify the unit, right? So first you need to find the dimension for each physics quantity. So here we have force. So to identify the dimension for force, this is first step, yeah. So force, we know the equation is MA, F is equal to MA, right? So we write down the dimension equation. Because of that, to find the dimension of force, M is represent the mass, so the dimension is M, capital letters of M. A, which is acceleration. So acceleration is LT minus 2, the dimension for acceleration. So we get that the dimension for force is MLT negative 2. Actually, if you're not sure the A, you can refer to the V. Because of A is actually V over T, but I'm not sure here because I just use the shortcut because we understood A, the unit is MS minus 2. So the dimension, of course, LT minus 2, right? ms minus 2, so the dimension is lt minus 2. Okay, for the area, we know that the area is length, the L times L, so the dimension is L square for the area. And for the V, we know that the velocity, meaning that you need to recall back the basic equation for that derived quantity. So you can identify the dimension for that derived quantity. So V is equal to S over T. After we write down the dimension equation, we know that the S is distance or displacement, so represented by the dimension of L. T is time, so remember the dimension for time is capital letters of T, right? Because of that, the dimension for V is LT minus 1. So this is only the first step. Of course, distance I not write down here because of distance is basic quantity. Of course, the dimension is L. So this is the basic things that you need to identify before you use the dimension analysis to deduce the unit for the constant neta. And we can conclude that from our first step, the given information is the dimension for force, area, velocity, distance, and also we want to calculate the dimension for the neta. So I just put the question marks, okay? And how we solve it? Okay, first step is referring to the equation given, you need to write down the dimension equation first, okay? So you write down the dimension equation because of this is the multiplication and division operation. So we just dimension each physical quantity, and then this is optional, which is because we want to find the unit for eta, neta. So we make the neta as the head of the equation. So we get this equation, and now we can substitute the dimension that we have derived here inside the equation. So how? It is like this. For example, F. F is MLT minus 2. So F is MLT minus 2. A is L square. Okay, referring to the given dimension here. And then L is L. As I said, distance is basic quantity. And V is LT minus 1. So from here, we can solve the dimension to get the dimension for the neta, okay, which is if you look at here ml, L square, here is L, this is L, you can solve it. So finally you will get that ml minus 1 t minus 1. Okay, am I right? Because of, for example, for t, this is t negative 2 and here t negative 1. Okay, so if we bring it at the upper, we get that t is equal to t negative 2 plus 1 is equal to 2 negative 1 at the upper part. Okay, so that's the way how we solve. So you get the dimension for eta, but the question said that you need to find the unit. So please read the question carefully. So because of that, you need to declare. Referring to the dimension analysis, you can identify the unit for neta, which is equal to for the m is the unit for mass, represent kg. The unit for mass is kg. L is the length, okay, which is m. So here L negative 1, so m also negative 1, and t is second, so s negative 1. So that's the way from the dimension analysis you identify the unit for the physical quantity. Okay, this is the first example. Okay, first question. Okay, second question. It's look like that it is quite complicated. Looks like complicated equation, but the step is same. Okay. If you refer to the question, a sphere of radius r and density rho s fall in a liquid of density rho f. Okay. If it achieve a terminal velocity given by the following expression. So it doesn't matter, either you have learned that topic or not, but you can use the related equation as long as you know each physical quantity inside the equation. So in this case, K is the constant, G is the acceleration due to the gravity, and we want to determine the dimension for K, for the constant. Okay, so this is K. Now I have highlighted the physical quantity that involved, which is radius. Radius is basic quantity. So density, velocity, and acceleration is the derived quantity. So the first step is we identify the dimension for the derived quantity first. So in this case, rho. That's why I said you need to remember the basic equation for the physical quantity. For the derived quantity, for example, density is equal to mass over volume. Okay, M over V. So we write down the dimension equation and we identify the dimension for mass, dimension for V, we get the dimension for the density, which is ml minus 3. Same to the V and also G. So V is velocity, G is acceleration. Previously, I have shown you how to get the dimension right. So now we can conclude that the given information, conclude for the given information only. So we have the R radius just now because of it is a length, so the dimension is L. Rho VG we derive here, and we want to find the K. So my suggestion, make sure that you know what you want to what the question wants. So normally I will give the question mark for that one. So I am alert in my equation supposed to finally I can get the dimension for K in this case. So what we need to do, firstly, you're supposed to write down the dimension equation. But if you look at the equation, this is a incomplete operation, right? Okay, so we need to extend the equation. So when we extend the equation, actually, we just get that the 2r squared g over 9k times this rho s, okay, because of s just now, the density of the sphere, okay, rho of f is the density in the fluid or in the liquid. Okay, so at the both this side is same, right? The physical quantity involved is same. So and this is the subtraction operation. How we write down the dimension equation? Remember that I said there are three types of equation. The way which is involved the additional, subtraction, multiplication, and division equation. So in this case, because of it is subtraction equation, so the way we write down the dimension equation is like this. Vt, the terminal velocity, at the left hand side of the equation is equal to the dimension is equal to the dimension for this equation and also the dimension for this part. Same. Why same dimension? Because of this is the subtraction operation. Okay, because of that, we want to find the K. Of course, K for at both sides is same, right? So we can choose one relationship only. So you can, because we want to find the dimension of K, so make the K as the head of the equation. Because of that, we get this dimension equation. And what next? Remember, I told you if we have the scalar here or if we have constant here, 2 over 9 is constant. So for the constant, the dimension for the constant is equal to 1. Dimensionless constant, which is no unit. 2 divided by 9 is no unit. So the dimension is equal to 1. And then R just now is L, so L square. So here, if you can see R square represented by L square. G is LT minus 2, VT is the terminal velocity. Doesn't matter the terms terminal velocity, but the main point is it is the derived quantity is the velocity. So the dimension is LT minus 1. And then for the rho density is ML minus 3. For the density, ML minus 3. So when you substitute in the equation and you solve the dimension, okay, you will get that the dimension for K is equal to ML minus 1, T minus 1. Okay, so the question want you to identify the dimension. So this is the way. The part that make you confused may be referring to the equation. Maybe you will feel that it is very difficult, but it is actually you need to understand the rules of the dimension equation. So when it is equal and when we need to multiply or when we need to divide. Okay. And then we go to the question number 3. So for question number 3, you need to show that the equation below is dimensionally correct. So actually question number 1 and 2 is referred to the first application of the dimension analysis, which is to identify either the unit or the dimension of the derived quantity. Okay, and question number 3 is to show the dimension. Actually, you need to show the homogeneity or dimensionally correct of the equation. You need to identify, do the Q here is equal, the dimension is equal to the dimension, the rest of the equation here. Okay, because of that, if you refer to the equation, we have here R is radius. Okay, I just highlight the physical quantity. Radius of the tube, L is the length, P is represent the pressure. That doesn't matter, it is a different in pressure or whatever, but basically it is a pressure. And then the difference between the N is the coefficient of viscosity. Eta, the symbol here is the symbol for if I'm not mistaken, neta or eta, something like that, coefficient of viscosity. So in this question, give because of we not familiar with the coefficient of viscosity, right? Maybe you not learned yet. So they give the unit which is Newton second per meter square. Newton second meter square. And Q is the volume rate of flow. Volume rate of flow. Volume is V, right? So kalau if rate, meaning that V over T. That's why the unit is M cube, meter cube, S minus 1. Meaning that the volume per unit time. Okay, so that's the derived quantity given in this equation with the basic quantity. What is the first step? So same, first step is you need to identify the dimension for the derived quantity first. Okay, referring to the question. Pressure, as I said, that's why again I remind you, you need to remember the previous equation, basic equation for the derived quantity. For example, pressure, actually it is equal to F over A. So the dimension is ml minus 1, T minus 2. Because of previously we have derived the dimension for force, mlt minus 2. Okay, for the neta, because of it is stated, it is the coefficient of viscosity with the unit of n as per meter square. So the dimension is, for the Newton is the unit for force, so mlt minus 2. So I put the dimension for n, Newton, mlt minus 2. The dimension for S is second, so the dimension is T. And the dimension for M minus 2, L minus 2, because M is meter. Okay, because of that, we get the dimension for the the coefficient of viscosity is M negative 1, T negative 1. And we have the Q. Q is represent the volume rate of flow, so V over T. V is L square, L cube, L power of 3 divided by T. So we get that the L power of 3 T minus 1. So this is the dimension for the related derived quantities inside the question. Make it clear first. Okay, that's the first step that I suggest to you. Now you write down, because you want to solve this question, you write down the final given information, which is we have the R, just now radius is L, the length is L, same because it is a basic quantity. Pressure, we have derived with the coefficient of viscosity, neta, and also the volume rate of flow. Okay, so after we identify each physics quantity inside the equation, the dimension for each physics derived quantity or physics quantity in the equation, we need to simplify the equation. Simplify meaning that in this case, you need to expand the equation. So when you expand the equation, you will see the relationship, which is a subtraction operation between these two terms, two parts. Because of that, when you write down the I just, because of this is to identify the homogeneity of the equation or to check the dimensionally correct of the equation. So I just divide by 3 steps. So the first step is same as before. You need to write down the dimension equation. So for the dimension equation, even here is the subtraction operation. So but for the dimension relationship, it is equal. Okay. And then what is step 2? Step 2, because we want to find the to identify either the equation is dimensionally correct, meaning that we need to check each terms inside the equation have the same dimension. So step 2, we need to do the analysis. Remember, we need to use the principle of principle of homogeneity. Principle of homogeneity. So principle of homogeneity said that at the left hand side, dimension for the at the left hand side of the equation is equal to the dimension at the right hand side of the equation. So in this case, because of our dimension equation is like this, so we can identify at the left hand side of the equation the dimension for Q, because of Q is located at the left hand side of the equation. So Q is L power of 3 T negative 1 given because we have identified earlier. Okay, so that's at the left hand side. So at the right hand side, we have two terms. Okay, two parts. So the first part, if you look at all the physics quantity involved is same with the second part, meaning that we can identify only one part. So for example, for the right hand side of the equation, when we identify pi over 8, this is the dimensionless constant. So remember, if for the dimensionless constant, it is equal to 1. Okay, So L, so because of this power of 4, so L power of 4, pressure is ml minus 1T minus 2. And then for the coefficient of viscosity, ml minus 1T minus 1. And for the length L, the dimension is L. So when you get this one, you can solve the, maybe you can cancel, for example, we can cancel the M and then solve the L and also T. Finally, you will get at the dimension at the left right hand side of the equation is equal to L squared T minus 1. Okay, in this case, for the second part, if you look at the equation is equal, right? P1 and P2 is still the pressure. So the same dimension. So no need for you to do like this for the second part. If you want to do it, it is okay. But because of we can see the dimension is supposed to be equal and the terms inside it, both side is equal. So we consider it is equal. Not consider, it is equal. And then for the homogeneity or to check either the equation is dimensionally correct or not, we compare at the left hand side, the dimension at the left hand side and the dimension at the right hand side. So even the right hand side, there are two parts. So we know that both part, of course, the dimension is equal. Okay, referring to the equation. So because of that, we can conclude that. So the third step, when you want to declare your answer, so you're supposed to say that the dimension at the left hand side of the equation is equal to the dimension at the right hand side of the equation, because you have proven here in the step 2. Left hand side is L power of 3T minus 1. At the right hand side, L power of 3T minus 1. So we say that therefore the equation above is homogeneous or dimensionally correct. So that's the way how we want to show that the equation is either homogeneous or dimensionally correct. Okay, I hope that you understand, because I just give one exercise or one example for this application. Okay, but the step is same. There are 3 steps. Of course, you cannot just show, but you need to declare your answer. Either it is dimensionally correct or not. Okay, do take note about that. And
Okay,
then,
Teacher Nun, sorry for the interruption, Teacher Nun. We have already go live for 30 minutes. So would you like to take a break?
okay.
Okay. So before we take a break, I will announce, okay, the 3rd digit code for credit claim. Okay, listen carefully, everyone. So the digit is number 6. The digit is number 6. Okay, so stay tuned, everyone. So let's watch an advertisement for a break.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.
Okay, welcome back, students. Teacher Nun, you may proceed with your presentation.
Okay, so everyone, let's take a look at question number 4. So actually, if you have tried to answer this question, you can write down your answer in the chat box. We can check either your solution is correct or not. But I'm sure that for the matriculation student, you not start yet the class, so you can try from the earlier explanation. Okay, so for question number 4, Bernoulli's equation relating pressure and velocity of a fluid moving in the horizontal plane is given as P plus half rho V square is equal to K, where rho is the density of the fluid, K is a constant. Determine the dimension of the constant K and its unit in terms of the basic unit. So we want to identify the dimension of constant K and its unit too. Alright. So referring to the equation, what you need to do first, I have highlight with the green color the physical quantity involved. Because of that, the first step, you need to identify the dimension for each physics quantity. So in this case, pressure, it is familiar with us, right? Just because of previously we have derived the pressure. So pressure is equal to ml minus 1, t minus 2. And then for the velocity, lt minus 1, pressure ml minus, density, rho is density. So density is equal to ml minus 3. Okay, so the given information here, referring to the question, these three physical quantity. And then as usual, we have the equation. So the first step is you need to write down the dimension equation. And in this case, if you refer to the equation, this is the additional operation. So for the additional operation, so what you need to do for the dimension analysis, so it is the dimension for each term inside the equation is equal. Because of that, referring to the equation, we can say that the dimension for pressure is equal to the dimension for the half PV square, rho V square, and also equal to K, either at the left hand side or at the right hand side, and consider the additional operation. Okay, so next what we need to do, because of we want to identify the constant K, right? The dimension for the constant K and also the unit for the K. And please take a look carefully at the equation. Don't find the long way to solve the question. You need to be very smart because of, if you look at the equation here, K is equal to P. Am I right? The dimension for K is equal to the dimension of P2. So we can use directly, because we want to identify the dimension for K first. So because of P is pressure, we have derived earlier, you can write down ml minus 2 t minus ml minus 1 t minus 2. Okay, so directly from the given information, you can get the answer. And the unit of the constant, because we know that ml minus 1 t minus 2, so the unit is m, referring to the kilogram, L is meter, so m negative 1, t is second, so t is s negative 2. So it is a very simple solution if you think before you try to solve the question. Okay, because of sometimes given the very look like quite difficult question, but the solution is very simple. Okay, as long as you remember to derive first the dimension for the derived quantities. Okay, this is actually, this part is very important. This is very basic, and I hope that you can try to derive all the physical quantity that you know, all the derived quantity, meaning that you need to identify the equation and then you can find the dimension. Okay, but don't worry, do not remember the dimension for each derived quantity, no need, because of you just need to remember the dimension for mass, length and time. So if you can remember that dimension, there's no problem for you to identify the dimension for the derived quantities. Okay, now we go to the question number 5. So for question number 5, this, because of this is the third application of the dimension analysis, which is to derive the equation. So this is more on STPM. Okay, so if you refer to the question, for a swinging simple pendulum, the period T is probably related to m, which is mass of the pendulum bob, L the length of the string, and G is the acceleration due to the gravity. So we need to use the dimension analysis to derive a possible relationship between T, M, L and G, meaning that we need to derive the equation that relate T, the period, with the M, L and G. So in this case, first step, what you need to do? So first you need to assume, you need to make assumption first, which is our assumption, or we can assume that the T is directly proportional to the M power of X, L power of Y, G power of Z. So we just assume because of X, Y, Z, it is integers, because we don't know yet. We want to find it. We want to calculate it using the dimension analysis. So from the relationship equation, we can write down the equation in this case. For example, T is equal to, we just can write down any constant, dimensionless constant. So in this case, we use K. So K, M power of X, L power of Y, and G power of Z. So now we want to find the X, Y, and Z. Okay, the blue colors. Okay, and I do the same thing for the physical quantity in this question. I just highlight so that you can remember the dimension for each physical quantity, because of all of this physical quantity we have derived before. Okay, so in this case, if you look at first step dimension equation, for the dimension equation, we have the T is equal to K, M power of X, L power, dimension of L power of Y, and dimension of G power of Z. Okay, and then we know that K, because of K is dimensionless constant. So for the dimensionless constant, K is equal to 1. Okay, it is equal to 1. Okay, now what we need to do, we need to do the analysis such as the principle of homogeneity, which is we consider the left hand side of the equation and also the right hand side of the equation. So for the left hand side of the equation, we have T. T is the period just now. So period, the unit is S, meaning that the dimension for T is capital letters of T. And then at the right hand side, we have K, M, a dimension of M power of X, dimension of L power of Y, and dimension of G power of Z. So when we write down here and we substitute the dimension, M is mass, so the dimension is M, like capital letters of M, L is length, so L, and G is acceleration, so LT minus 2. Don't forget the index X, Y, and Z. Okay, now what we need to do, because we want to find the X, Y, and Z, so we need to compare the dimension at the left hand side and the right hand side. So in this case, okay, listen carefully. When you compare between the dimension at the left hand side and right hand side, okay, because of the left hand side we just have T, right hand side we have the M power of X, L power of Y, LT minus 2 power of Z. So we can compare the index both sides. In this case, if T meaning that T power of 1, so it is equal to T, right? If L power of 0, meaning that it's equal to 1, look like that there's no value. So we just put it because we will compare the base here. We want to compare the base so that we can find the index of the integer X, Y, and Z. Alright, okay, because of that, we need to compare for index for each symbol on both side of the equation. So first, take a look at the M. So M at the left hand side, the power, the index is 0. At the right hand side is X. So we say that 0 is equal to X. We compare with the same base. And then for in this case, for T, okay, we compare the T because of from T we can get the Z first. So T at the left hand side is 1. At the right hand side is negative 2Z. So we write down that 1 is equal to negative 2Z. And you can calculate the Z will be equal to negative half. Okay. And how about Y or the base L? So for the L, at the left hand side is 0, right hand side is Y plus Z. So when we compare, when Z is here, Z is negative half, right? We just substitute. So you get Y which is equal to half, 1 over 2 only. Okay, now because of the question said that use dimensional analysis to derive a possible relationship. So referring to the value for each integer that we have calculated, we get that the relationship which is T is directly proportional to the M power of 0, L power of half, and G power of negative half. Or we can, in terms of equation, so we get that the relationship between the period is directly proportional to the surd L over G. So this is the relationship that the question wants. You suppose either you write down this relationship or you also can write down in terms of equation, also can. So this is how we derive the equation from the dimension analysis. Okay. Now we go to the second part of today's class, which is about the resultant vector. So for the resultant vector, it is a very the basic thing that you need to understand about the resultant vector is to resolve the vector into x and y component. We only resolve the vector which is the vector that not at the x or y component. And before you do the resolving vector, take note that if you refer to this, we have the x, and at this side, at the right side, we have the x, positive x axis. At the left hand side is negative x axis. Upward represent the y with the positive sign, and downward is y with the negative sign. Okay, so this is very important for the vector because a vector is we need to consider the direction. So we can mention either it is positive or negative, upward, downward, or positive or negative. Okay, so in this case, let's say how to resolve the vector. So as I said, we only resolve the vector for a vector that not located at the x or y component. If it is located at the x or y component, no need to resolve. We just use directly the value because it is represent the vector y and x. But in this case, for vector A, for example, so I just want to share with you, this is a very long time ago. to do the resolving vector. Okay, vector A just now, so we can sketch vector because of it is not vector A, not at the x or y component. So we need to resolve to vector A into x component and y component. So I represent by ax for x component and ay for y component. Okay, that's the first step. Okay, second step, we want to identify the magnitude of ax dengan ay, the magnitude of ax and ay. So I like to recall back. I am not sure either all of you have learned about Sohkatwa. Have you heard about the Sohkatwa? I'm sure this is very familiar, right? So I still remember until now, and we can use this one. For example, to resolve vector A, we can use sine theta. So sine is so, O is opposite, H is hypotenuse. So for the sine theta A opposite is represented by AY. AY, the vector AY is at the opposite side, and hypotenuse is A, vector A. So that's why we put the AY per A, and when we resolve, you get the AY is equal to A sine theta A. Okay, because of we resolve, we want to find the magnitude of component Y, AY. So how about component X? So we use cos, because of cos is K. K is adjacent per hypotenuse. Adjacent vector is AX. Hypotenuse is A. Because of that, we get the AX is equal to A cos theta A. So this is a very basic for resolving vector. How about if you have vector B, but the angle theta B is here. The angle is beside the y component, beside the y component. Here theta A is beside the x component, right? So this is different situation. So to resolve the vector, as usual, you need to sketch the vector at the x component and y component represented by vector B, which is bx and by. And then we do the same thing. We use the Sohkatwa, and for vector B, when we use the sine, so bx over b, because of, in this case, if you look at here, because of the angle theta B is here, opposite. So O is represent opposite. So opposite angle, opposite vector is bx. That's why bx over b. And we get that the bx is equal to b sin theta. It is different, right? With the different with the ax, right? Ax is cos, but bx is sine. So the reason is the location of the theta. And then for the cos theta b, of course, for the cos adjacent is by. So adjacent is by over b, hypotenuse is b. So we get the by equal to b cos theta b. Okay, that's the way how we resolve, referring to the different angle. So I hope that if you understand the basic part here, it is very easy for us when we discuss the exercise after this. And if you have C, we do the same thing, and the angle of theta C is beside the y component. So of course, vector C is supposed to equal to B, right? Which is Cx is sine, C sine theta C, and for the Cy, C cos theta C. So I hope that you, if you're not very clear, go through, listen carefully, repeat it again, so that you can understand, because of, I can see that 99% or 95% of a whole syllabus for the semester, you need to read it, it is involved the resolving vector. Okay, basically it is about the resolving vector. And what we need to so if you want to calculate the resultant vector, so this is vector ABC. So if you want to calculate the resultant vector, so we need to sum all of the vector at the x and y component. So in this case, sum of R is a resultant vector. Let's say I just represent the symbol R. So at the x component, okay, take a look here. AX is at the positive x-axis. So AX is positive, because we want to sum, so we plus with bx. But in this case, if you look at the direction of bx, that's why it is very important for you to resolve at the axis. So bx is to the left, which is to the negative x direction, so negative bx. Cx2 minus with cx, because of cx is also at the negative x-axis. Okay, because of that, we get that to calculate the sum of the vector at the x component, the magnitude of ax minus bx and minus cx. Okay, how about ry? Ry, because it is at the y component, so upward is positive, downward is negative. So in this case, if you look at here, ay is upward, by is upward, so ay plus by, but cy is downward, so minus cy, Because of that, we have relationship to calculate the sum of the vector at the y component, ay plus by minus cy. Okay, and have we get the total resultant vector? Not yet. So you're supposed to use to calculate the resultant vector r. So because we have the sum of vector rx and sum of vector at the y component, total rx and ry component. So we can use this equation to get the magnitude, and for the direction you need to find the theta. Theta, which is equal to shift tangent or inverse tangent, sum of sum of ry over rx. Okay, sum of ry, not rx. Because we refer to the tua, opposite adjacent. So normally opposite is ry, adjacent is rx. Okay, this is terbalik. Okay, sorry for that. Okay, now take a look at the question 6. Okay, this is very basic. We need to find the resultant vector for one dimension. One dimension, which is either A is x component, B is y component, C is x component, but there are two vector. Okay, so in this case, very easy because of it is at the x component only, one dimension, x component. So to the right, we consider positive, to the left, we consider negative. In this case, to calculate the resultant vector, the magnitude of the resultant vector, F2, because F2 is to the right, positive, F1 is negative, so F2 minus F1, 20 minus 50 is equal to 5 Newton. But remember, the question asks you to calculate the resultant vector. For the resultant vector, instead of magnitude, you also need to show the direction. So in this case, you can mention the direction is to the right. How you identify the direction to the right? Because of your resultant vector FR, if you look at the value, is positive 5 Newton, right? Positive meaning that it is same direction with the F2, which is to the right. Okay. And how about B? B, same thing. We do the same thing actually. Cuma for the B, the F1 is upward, F2 is downward. Upward is positive, F2 downward is negative. So F1 minus F2, F1 is 8, F2 is 3. It is also equal to 5 Newton. And the direction is upward because of the answer for the resultant vector is positive. Same direction with the F1. Okay. And how about C? C, to calculate the magnitude, because of both vector F1 and F2 at to the left, so both is negative. What we do is negative 8 minus plus with negative 6, because we want to find the sum, but the direction is in the to the left. Because of that, we get negative 14 Newton, and the direction we set that to the left because of the answer is negative. The sign is negative for the answer. And lastly, for D, both vector is to the right. So you can say that when you do the calculation, because of same direction, and to the right positive, so 5 plus 4 is equal to 9 Newton. And direction to the right. Make sure that you declare the direction. We cannot assume only. You need to state the direction because of resultant vector, meaning that you need to find the magnitude and also the direction. Even it is not stated magnitude and direction, but when it's said the resultant vector is supposed to consist of magnitude and direction. Okay. And for question number 7, okay, this is, I just want to share with you, for the 2 dimension, we have x and y component. Let's say this part, we no need for us to resolve the vector because of F1 and F2 both are at the x and y component. But how we want to calculate the resultant vector? So in this case, first identify F1, either the positive or negative. In this case, because of one vector only at the x and y component, so we just directly get Fx, force at the x component, so it is equal to F1 represented by F1. F1 is positive 16 Newton because of to the right. Fy, which is positive 14 Newton upward, that's why positive. So what is the magnitude? How you want to calculate the magnitude of the FR? Previously, if one dimension, we just add sahaja kan, kita tambah sahaja. But in this case, because of this is x 2 dimension, so to find the resultant vector for the 2 dimension vector, we need to use the equation, this equation to calculate the magnitude. So Fr is equal to set Fx square plus Fy square. Fx here is 16 and Fy is 14. Don't forget to square both numbers. You will get that the resultant vector magnitude of the resultant vector is 21.26 Newton. And remember, kalau resultant vector supposed to be with the direction. So to calculate the direction, normally we calculate the theta. So theta is equal to a shift tangent or inverse tangent Fy over Fx. That's the general equation. Y component divided by X component. So Fy just now is 14, Fx is 16. You will get that the theta is 41.2 degree. If you just leave your answer 41.2 degree, you will not get marks. You need to declare in what position. So how? How you want to know 41.2 degree above the positive x-axis or maybe below the positive x-axis? How you want to know? You just take a look at the F1 and F2, Fx and Fy. Fx is the positive direction, Fy also positive direction. So if we sketch the resultant vector, the blue vector, the blue arrow represent the resultant vector. So of course the theta is here because we take the inverse tangent just now, Fy over Fx. That's why we can identify that this theta is above the positive x-axis. You cannot say that the theta 41.2 from the positive x-axis. Cannot. Because we don't know either above or below the positive x-axis. You need to declare. Okay, same thing for the B. B because of F2, same thing because of F2 to the right positive, but F1, which is represent the Y component, is negative 25 Newton. So we have negative vector. In this case, to calculate the magnitude, no problem because our magnitude is not involved the direction. So we can use directly the equation and substitute the value. Do you need to substitute the negative 25? It is okay if you want to substitute or not. We consider because of it is power of 2 square. So finally you will get the same answer. Okay. So the magnitude for the resultant vector Fr is 39.05 Newton. And for the direction, okay, for the direction, same equation. Tengok, we will keep repeating doing the same equation. So I hope that this will help you to remember how to resolve the vector, how to find the resultant vector. So for the direction, inverse tangent Fy over Fx, we substitute the Fy which is 25, Fx is 30, and then when you calculate, you get 39.8. And then how you want to identify just now? Below the positive x-axis, as I said, you take a look at the Fx dengan Fy. So Fx is positive, Fy is negative. So the resultant vector represented by the green arrow. And then theta is here, meaning that this angle, which is 39.8, is below the positive x-axis. Below the positive x-axis. I hope that you can compare with these two solutions to understand how you want to identify either it is above or below the positive x-axis. Okay, now we go to the question number 8. Okay, for the question number 8, it is 2 dimension and 1 dimension, meaning that F2 you need to resolve into X and Y component. But if you look at F1, the head of the vector is at the tail of the vector F2. So we cannot solve if you leave it like this only. What we need to do to make the resolving vector easier, we need to make sure that the tail of all vectors acting at the same point. So because of that, we can sketch back the diagram, become like this, which is the tail of F1 is at the same point with the F2. Normally we refer to the origin, easier. So actually the given two forces vectors here, you can sketch like this. So it is very easy for you because you can see the F1 don't need to resolve. It is at the X component. We only need to resolve F2 to the X and Y component. So to here F1X, F1 because of, if you look at here, because of it is at the X component, so it is equal to 3 Newton. But F1Y, it is equal to 0 because of no Y component for F1. That's why I just represent 0. I write down the 0 to remind you there's no Y component. How about F2? For the F2, I just separate it so that you can see clearly what we need to do, how we resolve. F2 first, you need to sketch the X component and Y component for the F2. Okay, and then we find the magnitude of the X and Y component. So to calculate the magnitude or to identify the magnitude, we use the Sohkatua just now. Okay, I will not repeat it. I hope that you understand why F2x is cos, why F2y is sine. It depends on the position of the theta, and you get the magnitude of the X and Y component. Now, to calculate the resultant, these two vector F1 and F2, so we need to sum all the forces at the X component. So here X component, we have two forces. So we just add. Why we can add f2x and f1x? Because both of them are at the x component. And for the fy, because of f1y is 0, so the y component is only represented by f2y, which is 3.46 Newton. And to calculate the magnitude, we use the same equation, and you need to take a look at the sum of fx and fy to substitute in this equation. Take a look here, fx is 5, fy is 3.46 square. So we substitute, you get the magnitude of fr, and for the direction, we use the inverse tangent fy per fx. Same, we still need to refer to this one. And now, okay, the problem is you can calculate, you can do the calculation, you can get the correct angle. But how you want to identify either it is above the positive x-axis or below the positive x-axis? So as I said before, take a look at the sum of fx and fy, the sign. Both is positive, right? So if we sketch the resultant vector is supposed to be at the first quadrant, which is x positive, y also positive. And because of that, we can say that the angle or the direction, which is 34.7 degree, is above the positive x-axis. Okay, now you're familiar, right? You know how, I hope that you can see clearly how to identify the direction. Not only stated the theta, but you need to mention where the position of the theta. So I hope that we can continue a few more questions. So I think this question is same case with the question number 8. The problem is, if you look at these two vector, both the head is pointed at the origin. But if you want to solve the vector, if you want to do the resolving vector, the tail is supposed to exited at the same point. So what you need to do? So you need to rearrange the vector. So now in this case, vector S supposed to be, because of the tail, it's supposed to be at the origin, for example. So it is showing upward, still upward direction. And for the R, when we put the tail at the origin, so the R is like this. And do take note the theta. Make sure that you arrange the theta carefully. So theta is supposed to be 55 degree from the x-axis. So it's supposed to be at this side also from the x-axis. And what next? Okay, of course, because of R is not at the x and y component, we resolve the Rx and Ry. So when we resolve, we need to use the Sohkatua or Sohka to identify the magnitude of Rx and Ry, and then calculate the sum of forces at the x and y component for both vector. So this part, you need to consider the direction. So for example, for the Fx, Rx is to the left, so we get the negative sign. Sx, no Sx, because of S is only at the y component. So Sx is equal to 0. And for the Fy, Ry is downward, Sy is upward. So Sy upward is positive, so 14 minus 18.84. And then, if you look at here, you will get the answer for sum of forces at the y component is also negative. And actually from Fx and the sum of Fx and the sum of Fy, you can sketch the diagram. You can sketch the resultant vector actually, because of we know the x and y component at the negative sign. Okay, so the resultant vector is this part. So now we want to calculate what is the magnitude of this resultant vector and also the direction. How many angle from the negative x-axis. So we do the same thing because we have the sum of Fx and sum of Fy. We use the equation to calculate the magnitude. Okay, this equation and also the direction. And now you know how to identify either it is below or above the negative x-axis, right? So referring to the value for sum of Fx and sum of Fy. Okay, so actually for the resolving vector, we repeat doing the same thing. In this case, there are 3 vectors. So I show you, you need to resolve vector A and vector B. So make sure that you resolve to the x and y component using Soh and Kah rules just now, and calculate the sum at the x component and the sum at the y component. When you calculate the sum of the vector, you need to consider the direction. And the first part, when you resolve, we just resolve to calculate the magnitude of the resolving vector. The direction of the vector we consider when we calculate the sum of the vector at the x component and the y component. So when you get the resultant vector at the x and y component, you calculate the magnitude following the same equation. And also for the direction, we use the same equation and you substitute the sum of Sx and sum of Sy. Okay, and then as I said, to identify the direction either below or above negative x-axis, so you need to consider the sign for sum of sx and sum of sy, because of both is negative, so it is at the third quadrant. Okay, so this is the resultant, the vector and also the direction or the angle. Okay, so you can see that we just repeating the same time. I just give the different situation, the different arrangement of the vector. And this bonus actually, last question. Another way to solve the question, you also can use table for the resolving vector. Okay, I also advise you, if you want to see clearly, using table is easier. So in this case, we do the same thing. Just inside, we just substitute inside the table. For example, when we resolve ax and ay, we write down here ax, ay. Okay, and then b, bx and by. You resolve the bx and by, and c, cx and cy. After that, referring to the magnitude that you have calculated, you calculate the sum of the x component. So total up all of the vector. But when you want to total up, still make sure that, take a look here, you still need to consider the direction of the vector. Both, also for the sum of fy. Both vector, you need to consider either it is ax, bx, cx ni, which one is positive, which one is negative. You need to consider when you want to calculate the sum. So when you get the sum of the vector at the x component and the sum of the vector at the y component, what next? You calculate the magnitude, right? Using the same equation. Calculate the direction using the same equation. How to identify either it is above or below? You take a look at the sum of the x and y component. In this case, x is negative, y is positive. Because of that, if I sketch the diagram, it is located at the second quadrant. So the angle 31.3 degrees is actually above the negative x-axis. And this is the magnitude of the resultant vector. Okay, so I hope that it will help you to understand how to resolve the vector. Of course, if I'm not mistaken, topic 3, we learn about the forces. Specific for the forces, it is a lot of resolving vector. Also for the projectile motion in the topic 2. Boleh dikatakan for each topic, for the matriculation or STPM, it will involve the resolving vector, right, Madam Rosmaya, right? So okay, that's it. Thank you so much. Thank you, everyone. I hope that you take care of yourself, and I wish you all the best. Please give or leave the comment in my video so that I can improve my next presentation. And don't forget to subscribe my channel and also Madam Rosmaya channel. Okay, so that's it. I give back to Madam Rosmaya. Thank you so much. Okay, Madam Rosmaya.
Okay, so with God grace, we have reached the end of today's session. Congratulations to those who are able to follow our session from the beginning till the end. So before we end our session for today, I will announce the fourth and the fifth, the last 2 digits code for credit claim. So listen everyone, the digits are number 8, okay, number 8 and number 4. First number 8, okay. Then the last is number 4. Okay, so all of you, please stop posting your comments for a while. And if you haven't clicked the subscribe button, please do so. Make sure it turns to grey color, okay, not the red color. And activate the icon bell so that you will not miss the next class session. So then if you find that the lesson was beneficial, so click like and share to your friends on your social media. So spread and share the goodness. So once completed, type done on the chat box before the certificate link and credit claim link are given as a token of thank you for your dedication in joining the free online class today. So I will paste the link, okay, for the credit claim now in the chat box. Okay, then link for the ECGL. Okay, and lastly, for the username for Teacher Nun. Okay, so the certificate link and credit claim link are given already in the chat box. So please take note and the link will end half an hour after this live. Make sure to use the EDD email or the more email only to log in. Incorrect email used will not be entertained. So if you haven't got one, please apply. Okay, the link to apply the EDD email is also given in the chat box. So if you wish to get more information on the online classes, go to the www.academyyoutuber.com. And to those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thank all of the students for joining today. Remember that the more classes you join, the more credit you can claim. So feel free to share this free tuition class to your friends and teachers all over Malaysia, because this is a collective effort from all the teachers throughout Malaysia for all the students throughout the country. So thank you too for being a YouTuber Academy supporter too. So I think that's all for now. See you in another session. Ingat the hashtag. Okay, remember the hashtag bermula percuma and selamanya percuma. So Assalamualaikum. Stay safe till we meet again next week on the same day, same time, which is on Sunday at 5 p.m. Okay, so bye-bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.